This video is to get us familiar with the radian angles around the unit circle, for the special angles at least. It would take too long to always have to convert the radians to degrees, so we need to learn the radian measures and become comfortable with them. We've already talked about how a full circle is 2 pi, so a full spin is 2 pi along with being 0 radians. It would also be 2 pi if I do a full spin, which then means a half circle is pi, which makes sense. And if I slice pi in half, I get 90 degrees, which is pi over 2. Again, makes sense. Now here's where the hitch comes from. The way I teach this is if you can count, you can figure out the radian measures. So here's what I mean. To go from 90 degrees down to 30, I would divide by 3. So in terms of radians, to go from pi over 2 radians down to whatever 30 degrees is in radians, I would also divide by 3. That's timesing by 1/3, pi over 6. So 30 degrees equates to pi over 6 radians. If you know that relationship and you can count, you can get every increment of 30 degrees. So what we're going to do here is do just the blue angles, and it also is going to hit the black angles as well. But so we're going to skip over those reds that you can see on here. If I know that 30 degrees is 1 pi over 6, think of it as 1 pi over 6. Then another 30 degrees would be 2 pi over 6. Which we reduce to pi over 3. Another 30 degrees would be 3 pi over 6. Which we reduce to pi over 2. Another 30 degrees, 4 pi over 6. Which we reduce to 2/3. And you just keep going. 5 pi over 6. 6 over 6, which is pi. 7 over 6, 8 over 6, 9 over 6, and again, if I can reduce, I do. 10 over 6, 11 over 6, 12 over 6, 12 pi over 6 is 2 pi, and I'm back where I started. If it was a negative angle, you would just do the same thing in the opposite direction. So again, as long as you know that 30 degrees is pi over 6 radians, in particular 1 pi over 6 radians, then just keep counting 2, 6, 3, 6, 4, 6, and keep on going through that. Obviously, you'll also see you need to be really good with fractions to do radians because we often write them in fractional form. So again, as long as you know that every pi over 6 is 30 degrees, you're good. Now, the only other one to really worry about, because that covered the 30s and the 60s, is the 45s. So every 45 is pi over 4, which again, if I know that 90 degrees down to 45 degrees, well, that's divide by 2. Then to go from 90 degrees in radians, pi over 2, I would divide by 2. Pi over 2 divided by 2 is pi over 4. Again, if I know the relationship that 45 degrees is pi over 4 radians, in particular, 1 pi over 4 radians, and I can count, then I can do all the 45 marks. So, again, 45 degrees is 1/4. Another 45 degrees from there would be 2/4. This would be, the pen's having a little trouble today, 2 pi over 4. which again reduces to pi over 2. Another 45 degrees, 3 pi over 4. Another 45, 4 over 4, which reduces to pi. 5 over 4, 6 over 4, which reduces to 3 over 2. 7 over 4, 8 over 4, gets me right back to my 2 pi. And again, if it was negative, you just go the opposite way. So basically, if you're dealing with a 30-degree or 60-degree reference, if you're given an angle that's pi over 6 or pi over 3, something over 6 or something over 3, just count by increments of 1/6. If you're given something that's something over 4, count in 45-degree increments and just go around the circle. And I'm going to do that several times as I'm going through the lessons here. I still count every time I do it.